So we looked in the last section at solving inequalities, and now we're just going to do our final section on inequalities, which is to look at solving double inequalities. So here, for example, we're told that 2x minus 3 must be bigger than 7, but is smaller than or equal to 11. And what we're trying to do is trying to find the range of values that x can take. And the way we're doing that is we're going to use inverse operations to get x on its own. So if we think what's happening to x, here I'm timesing it by 2 and then subtracting 3. So going back the other way, the first thing I'm going to need to do is to add 3. So here I'm going to add 3, but I'm going to need to do that to both my 7 and to my 11. I'm going to add 3 to both of them. So now I'm going to keep my symbols exactly the same. So this is a strict inequality, this is not strict. I've got rid of my minus 3 by adding it, so I can say that 2x here, 7 plus 3 would give me 10, and 11 plus 3 would have given me 14. So that tells me that 2x is greater than 10, but less than or equal to 14. Now I want to get x on its own, so the last step on my flow diagram would be to divide by 2. So I'm going to divide both my 10 and my 14 by 2. Divide by 2, not divide by 10, divide by 2. And again, my symbols are the same. So I've got my strict equality, my not strict inequality. That tells me that x is greater than 10 divided by 2 is 5, 14 divided by 2 is 7. Now, it wanted me to find the integer solutions, so I know that x is bigger than 5 but less than or equal to 7. So x cannot be 5. It could only, if it's a whole number, be 6 or 7. I'm just going to recap on what I did here using a flow diagram, because here we've got x times by 2 subtract 3 gave me 7 and 11. I've got my two solutions. So working back the other way, add 3 and divide by 2. Well, my 7, when I add 3 is 10, divide by 2 gave me my 5, which is where this 5 comes from. My 11, add 3 and divide by 2 gave me 7, which is where that 7 came from. Okay, so thinking about the same method here, I've got x, I'm taking away 3 and dividing it by 4. And on the left hand side I've got 0, and on the right hand side I've got 1. So going the other way around, I'm timesing by 4 and adding 3. I'm trying to get x on its own. 0 times 4 is 0, add 3 is 3. So down here I can say that I'm going to have a 3. Symbols stay the same. My 1 times 4 is 4, add 3 is 7, so that I know that x is greater than or equal to 3, but less than 7. So it could be 3, 4, 5, or 6. It can't include 7. Okay, I'm going to pause the video there, and then I'm going to give you some questions to try yourselves. Okay, so here's 6 questions for you to try. I'd like you please to try and set them out as we did before, and to, once you found the inequality, to also find the integer solutions which satisfy it. Pause the video now, have a go at them, and then unpause when you're ready to continue. Okay, so I'm just going to take us through the method for the first couple of examples. So the first thing I did was to copy out my symbols, so this is less than or equal to, this is strictly less than. Then done my flow diagram, x times 3, put in my two limits, 12 and 18, working backwards. The inverse of timesing by 3 is dividing by 3, 12 divided by 3 is 4, 18 divided by 3 is 6, so I know my two numbers in there are 4 and 6. X is strictly greater than or equal to 4, but less than 6, so it could be 4 and 5, cannot include 6, so those are the only two possible numbers. Done exactly the same here for x minus 2. I needed to add 2 to both sides, so it tells me it's between 1 and 4, so it can only be 2 or 3. Here I've needed to times both sides by 5, So it gives me minus 5 and 0. So my possible solutions are minus 4 all the way up to minus 1. Needed to subtract 2 from both sides to give me minus 3 and minus 1. So my possible solutions are minus 2 and minus 1. Notice that minus 1 is included because it's not a strict inequality. Minus 3 is not included because it's strict. Here I needed to subtract 3 and divide by 2. So subtracting 3 and dividing by 2 gave me 0 and 2. So my limits are 0 and 2. The possible values are 0 and 1. And here the possible values are 6, 7, 8 and 9. If you manage to get 6 out of 6, incredibly well done on that. That's really, really difficult stuff, and it's right at the top end of the foundation paper, and you'd expect to see that on questions 23, 24, 25 on a typical paper. If you need any further assistance on those, please take a look at Hegarty 272 and give yourself a mark out of 6 for me. Alright, very well done.